All right, so in our last class, we looked at dividing polynomials. And what that is kind of the first step to factoring polynomials. And like I mentioned at the end of last class, what's going to end up happening is after we've factored the polynomial and broke it down into several pieces, eventually what you're going to get down to is a quadratic equation that you're going to have to factor. And so again, I went over it earlier today, one quadratic equation, but I know there's two different ways that teachers teach factoring quadratics. Again, I use what I call the chart method, where some teachers will use decomposition. I've always found the chart method works way, way better. It's way, way easier. So I'm just going to go through a couple of examples of factoring a quadratic. And so, again, using my chart method, I have to draw a chart. Now, my first term goes in the top left corner. That's the 12x squared. All right, and then my last term goes in the top right corner. Now, again, there's 4 spots here. Let's put little dots that we have to fill out. Now, on the left-hand side of my table, what I need is two terms that multiply to give me 12x squared. All right, and so I'm going to try, say, I don't know, 4x and 3x. Now, there is some trial and error to this because as you saw earlier today, I didn't get it right the first time. Now, two things, I guess in this case, numbers that multiply to give me 3. I'm going to go with 1 and 3. All right, now again, you can't just come up with two terms and assume that you're right. You have to cross multiply the terms and then add them, and they must equal your middle term here. All right, and so in this case, when I go 4x times 3, that's a 12x. Then plus 1 times 3x, which is 3x. So I have a 12x plus a 3x. That's 15x. That doesn't work. All right, so I'm going to switch these numbers around, see if that helps. I might have to switch these two or try something else. So we'll see. I'll go with a 3 and then a 1. All right, so now let's see here. Cross multiply again. 4x times 1 is 4x. Then plus 3 times 3x, which is 9x. So I have a 4x plus a 9x. Check that out. I got it. It is 13x. And so if I factored this polynomial, 12x squared plus 13x plus 3, I just write the factors as they are in the table across. So my first factor would be 4x plus 3 because it's a positive 3 over there. And then my next factor, again, I'm just reading across horizontally, would be 3x plus 1. And there we go. All right, so let's try another one here. We have 3x squared minus 10x minus 8. All right, so I'm going to do my table once again. My first term goes in the top left. And my last term, got to watch your sign here, the minus 8, goes in the top right. All right, so I'm looking for two terms that multiply to give me 3x squared. I'm going to say 3x and an x. Or 3x and a 1x, if you will. All right, minus 8. I'm going to say a minus 4 and a 2. All right, so are those right? Let's check it out. Again, cross multiplying. 3x times 2 is 6x. Then I have minus 4x. So 6x minus 4x, that's 2x, not even close. I don't know. Let's switch the numbers. So let's see here. What did I have here? I think I had a 2 here or a minus 4 there. So I'll put the minus 4 on the bottom and 2 on the top. And sometimes you got to switch both of them. You got to play with both sides. Again, it's a trial and error. But again, it gets you better with your multiplication tables. All right. So 3x times a minus 4. That's a minus 12x plus 2x. So I get minus 12x plus 2x. That's minus 10x. Bingo. That's our middle term. And so if I factored this quadratic, again, reading the factors across horizontally, I got 3x and then a positive 2. And then the other factor here will be the x minus 4. And there's our quadratics factored. Again, there is another way to do it. It's decomposition, but I find this way a lot easier. And with decomposition, there's 3 different ways. And with this table, there's only one way to do it. So it works out really well because you only have to learn one way. All right. Now, again, this is because we're factoring polynomials. This is kind of going to be our finishing move. But now what we're going to look at is the start. All right. Whoops. And what we're going to use is what's called the factor theorem. Now, again, it's generally used for polynomials of degree 3 or higher because we already know how to factor a quadratic and we know how to common factor. All right. Now, the factor theorem's got 2 parts to it. And I'm going to explain these because they might not make sense initially, so we're going to use these up. Now, the first one is that when a polynomial f of x, so there's our function, our polynomial f of x, is divided by a factor of x minus a, the remainder is equal to f of a. All right, so we'll talk about that. But again, when a polynomial f of x is divided by x minus a, the remainder is equal to f of a. The second part of the factor theorem, which is definitely going to help us out for factoring polynomials, is that if x minus a is a factor then of f of x, of our function, then f of a, well, this is something we talked about earlier, is equal to 0. Because if a factor, or if something is a factor of a polynomial, it means you have no remainder, right? 0 remainder. And that's something we had earlier. Now, if it isn't a factor, then you are going to have a remainder and it's going to equal f of a. Now, this is written right out of the textbook, and this is the kind of thing you'll find on the internet. But the essential thing is you're looking for the number that makes our factor equal to 0. Right? And so if I put an a in here for x, a minus a is equal to 0. So that's kind of what we're looking at. And again, I'll go through that as we do some questions here. All right. So on that note, is x minus 1 a factor of the polynomial x to the power 4 minus 7x cubed plus 2x squared plus 9x? I want to know if it's a factor. Now, earlier this morning, we did division, and we showed that it had a 0 remainder to prove that it was a factor. But we don't have to necessarily do that with the factor theorem. Here's what I'm going to do. I'm going to take this x minus 1 and set it equal to 0. All right. And so all I'm going to do is move that minus 1 over to the other side. And so x is equal to 1. So what I'm going to use in this factor theorem is that if x is equal to 1, I'm going to substitute it into my equation. And if the answer is 0, it is a factor. Because again, when I substitute that value of x equals 1 into the polynomial, it's going to tell me what the remainder is. That's, again, what our factor theorem is all about. Right? So I found out this factor, I set it equal to 0. I found out what my a value was. In this case, it's just 1. And now I'm going to sub that 1 in and find out, hey, what's the remainder? If it's 0, it's a factor. If it's not 0, then it's not a factor. So here we go. F of 1, because that's the a value, if you will. We have 1 to the power of 4 minus 7 times, again, subbing in for x, I'm going to have 1 to the power of 3. The next term is 2x squared. So I'm going to have a plus 2, subbing 1 in for x, and it is squared. All right, plus my last term there, which is 9 times x. And again, our x value is 1. Extend this out. All right, so I'm just doing some calculations here again. Got to follow Bedmas. So I substitute, let's see, I'm going to do 1 to the power of 4. Well, that's 1 times 1 times 1. times 1. All right, then the next term, I have 1 to the power of 3. Again, that's just 1 times 1 times 1. And then I times it by minus 7. So I'm going to get a minus 7. All right, our next term there is 1 squared, 1 times 1, then times it by 2. I get a 2. And then lastly, well, I just have 9 times 1. That's a 9. All right, so what do we end up with here? 1 minus 7, well, that's a minus 6. Plus 2 is minus 4. And then add 9. We get a 5. Is the remainder. If we did the division, we're not dividing, but if we did, 5 is a remainder. And because it does not equal 0, this is not a factor. X minus 1 is not a factor. Anybody have any questions about that? Not so far. All right, I'm just checking the chat. Okay, I'm going to do another one of those. All right, so state the remainder when 4x minus 10 is divided into the polynomial 2x cubed minus 5x squared minus 2x plus 5. All right, so I want to find the remainder. All I got to do is, there's my factor. I'm going to set it equal to 0, all right, to see what number I'm going to substitute into the equation. And so I'm going to look at my 4x minus 10. I'm going to set it equal to 0. Again, to see what value I'm going to substitute into that polynomial. So I'm going to bring the negative 10 over to the other side. Again, changes sides, changes sign. So now it's a positive 10. All right, now I'm going to, of course, divide both sides by 4 to get x by itself. And this time I get the x value is 2.5. Or in terms of our factor theorem, that would be our a value. All right, so now I'm going to substitute that x value into our polynomial here and see what the remainder is. Just like I did up in the first example, I substituted in 1. All right, so here we go. So I'm going to put f of 2.5 into this equation. And I better grab my calculator if I'm going to do that because it's a decimal. There we go. All right. So let's see here. So the first term is 2x cubed. So that's going to be 2 times 2.5 to the power of 3. All right. Then we got minus 5. Our x value, again, substituting in is 2.5 to the power of 2. All right. Then we have minus 2x, or minus 2 times x. So I got to put 2.5 in there. And then lastly, we have our constant term of just a 5. All right, so again, I got to follow Bedmas here. Got to do the exponents first before I ever get to the multiply. All right, so I take 2.5 to the power of 3, and then I multiply it by 2. Okay, and I get 31.25. All right, then I take 2.5 squared, and then times it by a minus 5, and I get minus 31.25. All right, and then let's see, I got minus 2 times 2.5. Well, I know that's a minus 5, and then I have a plus 5. Now, if I get 31.25 minus 31.25, and then subtract 5 and then add 5, guess what? 0 is the remainder. Now, not only is 0 the remainder, but in terms of our factor theorem, that means that therefore, little side note here, 4x minus 10 is a factor, which again means if we took our original polynomial here and divided it by 4x minus 10, I would get a remainder of 0, which the factor theorem here is telling me. All right. Any questions so far? Let's check out the chat, because we're finally going to get to the part where we are factoring polynomials. All right, so how does all this tie in? Factor x cubed minus 5x squared minus 2x plus 24 using the factor theorem. All right, so here's our problem. Here's where things are gonna, here's where we're at, is I'm going to factor this thing. So I'm going to use division. So I got my x cubed minus 5x squared minus 2x plus 24. Now, if I'm going to factor this, I have to factor it by something that has a zero remainder. Problem is I don't have this other thing. Here's the key here. We're going to use the factor theorem. So I'm going to plug in a number. I'm going to have to pick numbers and figure out which number is a factor. And so if I tried 1, f of 1, I sub it in and let's see here. So 1 cubed is 1. Then I have minus 5x squared. Let's see here. That's going to be a minus 5. I substitute in a 1. Then sub a 1 in for minus 2x. I'd have a minus 2. And then a plus 24. Yeah. That is not equal to 0. I know that much. Let's see. I got a minus 6. I think that's a plus, or it's not even 0. So it's not even mattering here. Minus 7, minus 6. That's a 18. That's not helping us. We need a 0 remainder. But I will tell you this. If I put in a minus f of negative 2, watch what happens. And so again, you got to try numbers like 1, 2, 3, minus 1, minus 2, minus 3. But to save time here, I put in a minus 2. Well, x minus 2 cubed is minus 8. Minus 2 squared would be 4 times minus 5. That's a minus 20. Put in a minus 2 here. Well, I have minus 2 times a minus 2 when I have the minus 2x. That's going to be a plus 4. And then I have a plus 24. Now, when I add these numbers up, I get a 0 remainder. Here's what that tells me. That because my x value is negative 2, that means x plus 2 is a factor. And the reason it's x plus 2, because again, if I put a minus 2 in for x, that gives me 0. So it's always the opposite. It looks the opposite. Is there any questions about that? It's a little tricky. But again, you got to try different numbers. And I'm always going to make it low numbers to start, right? Like 1, 2, 3, minus 1, minus 2, minus 3. So now that I found that x plus 2 is a factor, I know that that's the term that I am going to divide by. And by the way, there might be more than one answer. But it's just all the answer in the end will be the same. So I'm going to put my x plus 2 here. That's what I'm going to divide by. So now I'm going to divide my polynomials. So I have x. How do I get from x to x cubed? I times it by x squared. All right, so now I go x squared times x cubed. X squared times 2 is positive 2x. All right, so now I have to subtract. X cubed minus x cubed is no x cubed. And then I have minus 5x squared. Whoops. This is a 2x squared. Forgot to put that in there. Minus 5x squared minus 2x squared. That's a minus 7x squared. And then, of course, I got to drop these two terms, the minus 2x and the positive 24 down. Okay. Continuing on. Now, how do I get from x to minus 7x squared in terms of multiplying? I would have to multiply by a minus 7x. All right, so minus 7x times x, minus 7x squared. All right, then a minus 7x times 2, minus 14x. All right, so again, I'm doing my subtraction. Minus 7x squared minus minus 7x squared. That's gone. The 7x squareds are gone. But then I get minus 2x minus 14x. A lot of minuses going on today. So again, the minus signs come together to be a plus 14x. So minus 2x plus 14x, 12x. And of course, I got to drop this 24 down, positive 24. All right, now next up, the last one here, because I'm going to get a number, x. How do I get from x to 12x? Well, I times it by 12. All right, now 12 times x is 12x. And then 12 times 2 is 24. And of course, as the factor theorem predicted, I'm getting a zero remainder when I subtract these two, because 12x minus 12x is 0, 24 minus 24 is 0, and so we have a zero remainder. So now here's what's going on here. Our equation here can now be written like this as factors. I have x plus 2 times x squared minus 7x plus 12. But I want to completely factor this equation. So now I'm going to factor, and as I mentioned, I'm going to factor this quadratic. So I'm going to factor my quadratic. So again, my first term, the x squared term, goes in the top left. The last term, the positive 12, goes in the top right. Doing my chart method. Well, I need two terms here that will give me x squared. X times x will. And anytime you get an x squared, it's always going to be x and x. Then I need two numbers that multiply to give me 12. Okay. And then when we crisscross, we get minus 7x. Okay, so I'm going to try a 3 and a 4. Now watch this. Cross multiply. I got a 4x plus a 3x. That's 7x. But I need a minus 7x. Now watch this. I'm going to put a minus sign here and a minus sign on the 4. Because still, minus 3 times minus 4 does give me a positive 12, right? Multiplying two negative numbers gives you a positive. But now when I cross multiply, I've got negative 4x, then minus another 3x. That gives me my minus 7x. And so now my polynomial fully factored. The first part we found was the x plus 2. And then we factored the quadratic. So we're going to get an x minus 3 is one factor. And then the other one is going to be an x minus 4. And that is that polynomial fully factored right there. And that's in factored form, which we looked at not last class, but the other day in terms of writing down a polynomial in factored form. All right, let's try one more of those guys. This time we have a degree 4. Yikes. Factor 4x to the power of 4 plus 6x cubed minus 6x squared minus 4x using the factor theorem. Now, here's one thing. Is I've noticed something here that every term here has an x. And actually every term is an even number. So if you can, and it's possible, common factor if possible. It shrinks the work, which is always a good thing, if you can do it. So again, I see that every term is it's even, so I know I can factor out a 2, and every term has an x. So the first term now will be, I'm going to put this in square brackets. There we go. 2x cubed. All right, so that's factoring out the 4x to the power of 4. And then let's see, the 6x cubed. I would have to multiply by a 3. Whoops. A 3 plus 3. Then I need an x squared. All right, and then the minus 6x squared, well, that's going to be a minus 3x. And then a minus 4x, that would just be a minus 2 if I common factored. There we go. So what I just did was I common factored out this 2x. So that's like my first piece. But now I'm going to factor out 2x cubed plus 3x squared minus 3x minus 2. So I'm going to factor that part out now using the factor theorem. So what I need some number that if I plug it in, will give me 0, because then I know it's got a 0 remainder. So I'm going to call this new function. If this is f of x, the original here, I'm going to call this one h of x. So again, h of x is going to equal 2x cubed plus 3x squared minus 3x minus 2. All right, so again, I got to plug numbers in like 1, 2, 3, -1, -2, -3. Whatever one of those gives us a 0 remainder, that's going to be a factor that we're going to use. So I don't know, I'll just try one out here, h of 1. I'll try x equals 1 and see if it works. Again, trial and error here. So let's see. X to the power of, so I'm plugging in 1 for x. All right, so let's see. 1 cubed is 1 times 2 is 2 plus 1 squared, okay, is 1 times 3 is 3. And then minus 3 times 1 is minus 3. And then a minus 2. Hey, all right. 0. We get a 0 remainder if I plug in x equals 1. So that means, therefore, x minus 1 is a factor. Again, when we're looking at using the factor theorem is what number for x would make that factor equal 0, right? So x minus 1 is the factor we're going to use. So again, it always looks the opposite. So now we're on to polynomial division. So there's our new function here, 2x cubed plus 3x squared minus 3x minus 2. And I just found out the number or the factor that we're going to use to divide is x minus 1. All right. So here we go with polynomial division. How do I get from x to 2x cubed? I would have to multiply by 2x squared. All right, so now 2x squared times x, that's our 2x cubed. But then we got to take that 2x squared and then times it by minus 1. So it's going to be a minus 2x squared. All right, so now I do my subtraction. So 2x cubed minus 2x cubed, that's nothing. That's why we did it. All right, but then we get 3x squared minus 2x squared. So there's that double negative again. So it's a positive. So 3x squared plus 2x squared, 5x squared. All right, we drop the minus 3x and the minus 2, come down. All right, on to the next one now. How do I get from x to 5x squared? I'd have to multiply by 5x. All right, so then 5x times x, that's 5x squared. That's what we wanted. Then 5x times a minus 1, minus 5x. All right, now we got to subtract. 5x squared minus 5x squared, they're gone. Minus 3x minus 5x. Again, the double negative is going to give us a positive. So minus 3x plus 5x, 2x. And then we drop the minus 2 down. All right, now, I shouldn't say that. We got to do the 2x. So how do I get from x to 2x? Multiply by 2. So 2 times x is 2x. 2 times -1 is -2. And guess what? We subtract those. We get a 0 remainder because it is a factor. The factor theorem told us that. All right, so now we're not done yet here. We're getting there. Just a little recap. So this top function here is our f of x. That's what we're trying to fully factor. So here's what we know at this point. That our function, f of x, number 1, originally, I factored out a 2x there. I common factored out a 2x. I just found out that x minus 1 is another factor. And then I have this quadratic here on the top, which is our 2x squared plus 5x plus 2. So here's what I'm going to do. Just as I did before, and I mentioned this, I'm going to factor this quadratic out. And then I can write f of x fully factored. So here we do a little more quadratic factoring. Again, my first term is the 2x squared. I put that in the top left. My last term, the positive 2 in the top right. All right, so I need two terms that give me 2x squared. Well, I'm just going to say it's 2x and x, 1x. And then 2, there's not a whole lot to do here. I'm going to go with 2 and 1. All right, so I cross multiply. 2x plus 2x, that's 4x. I need 5x. So I got my numbers in the wrong order here somewhat. I don't know, it doesn't matter. I'll switch these guys this time. Let's go with 1x up top and 2x on the bottom. And now when I cross multiply, I got 1x plus 4x. That gives me my 5x. So I've got my quadratic finished up. And so now, after all of that, here's my f of x. Like I said, I common factored out the 2x to begin. Using the factor theorem, we found x minus 1 was a factor. Then the other factors just got by quadratic. So on the top row there, we have an x plus 2. And then the second one, or the last one, we have the 2x plus 1. So we just factored out a polynomial of degree 4 using the factor theorem. And again, quadratic factoring is always required in the end, or just about always required in the end.